Welcome to Study Loop.
Okay, this is chapter 11, section problem 52, and it asks us when a thin glass tube is put into water, the water rises 1.4 centimeter. When the same tube is put into hexane, the hexane rises only 0.4 centimeters. Explain. So I've kind of just drawn this really easy to understand example anyway, but if we put a tube that has very thin, um, a thin diameter, the inner diameter of the tube into water, the capillary action is what draws the water molecules through that tube. And capillary action, as described by your textbook, really is a combination of two forces primarily that act against gravity. The first is the cohesive forces of the liquid molecules to interact with each other, and the other force at hand is adhesive force, which describes the interactions between the liquid solvent molecules and the surface of the tube. So the reason why water will rise further in a given tube than hexanes is because of an increase in the adhesive forces. So the water molecules are more strongly interacting with the sides of this tube and are being pulled up the sides of the tube. And this can happen because, like, if glass is like silicon dioxide or something like that, or right, like the water molecules can kind of interact with the sides of these tubes. And if one water molecule is kind of pulled up, it will pull the chain then of molecules up the tube via the cohesive forces. So it's a combination of these two things. It's the water molecules being pulled up the tube by the adhesive forces to the sides of the tube, and then that draws the rest of the column up with additional strength by the cohesive forces of each molecule to each other. And then also, the molecules will interact with the tube along the way, and that'll kind of help pull the liquid up the tube. However, hexane, won't interact with the same types of surfaces that water will. So because it's a very nonpolar molecule that doesn't participate in hydrogen bonding, it won't be able to really be pulled up through the same kind of adhesive forces. And furthermore, the cohesive forces are different too. So anyway, that's what this question is really trying to get at here. Okay, good luck studying.